Welcome back to a new episode of The Technology Addicts, the podcast from Avnet Abacus. At first glance, farming might seem antiquated. Think wheelbarrows, cowbells, and barbed wire. But over the past decades, a quiet revolution has turned agriculture into a hotspot of IoT innovation. Connected technologies like livestock trackers, remote sensing drones, and autonomous tractors have transformed the industry into one that's perhaps astonishingly high-tech and data-driven. And with AI on the rise, this shift is only accelerating, enabling real-time agricultural data management to boost productivity and sustainability. Behind this transformation is a vast technological arsenal, rugged devices built to withstand the elements, mechanical stress and vibrations, and challenging operating conditions like limited power and connectivity. Pry them open, and you'll find at their core powerful embedded devices, modular computing solutions that offer a robust, scalable, and efficient foundation for all sorts of demanding smart agriculture applications. And these hidden heroes will be the focus of today's conversation. Joining us to share his extensive experience in smart agricultural solutions is Bevan, Manager Vertical Markets at TRIA, formerly Avnet Embedded. Bevan and I will discuss the latest trends in agricultural IoT, the biggest challenges OEMs face in bringing solutions to market, and real-world projects that showcase how innovation is reshaping modern farming. Hi, Bevan. Thanks for joining me today.
Hello, and thank you for having me.
So, to start, could you introduce TRIA to our listeners and share how they're related to the Avnet family?
Yes, certainly. So, TRIA Technologies, in essence, designs, creates, and delivers embedded HMI, compute, and software for OEMs that need to embed technology into their products. TRIA is actually part of the Avnet Inc. family and is a global leader in embedded compute and full custom design and manufacturing services within the embedded space. So we design and manufacture through our services and facilities based in Europe, predominantly in Germany and Malta. And we have a vast experience in multiple vertical segments such as smart agriculture, medical, EV charging, and industrial automation. We also have the widest range of standard compute modules such as SMARC, Q7, OSM, and COM-HPC, for example. With this very wide selection, we also have an extreme selection of silicon partners that offer a diverse range of performance versus price options to our customers. And wrapping that all up, we also have the services from our core business units such as Silica, Abacus, and EBV for things like IP&E within the smart agricultural space.
All right, thanks for that. So IoT has been a buzzword for years now, but it's one of those that's been truly transformational. Can you talk about how IoT has impacted agriculture? Like, what are some key use cases that illustrate this shift, and which technologies do they rely on?
Of course, yeah. So IoT is, as you say, a very broad spectrum word and buzzword. IoT has transformed a lot of vertical segments, but in particular, if we look at smart agriculture, it has a very large impact in the fact that we have multiple types of sensors available to us now, whether that's air quality or soil quality, or even things like managing water tables from aerial topography via things like drones. IoT, basically for the smart agricultural space, relies on sensors and data to be aggregated and managed by AI technology. So things like agricultural machinery being able to run autonomously via IoT connectivity, or even things like crop management via thermal imaging and sensor data. IoT has really transformed how we actually look at the agricultural space and what we can do within that. It also enables us to take that data and learn from it for future generations, where we can understand a bit more about how the soil and the air temperature, the water tables all work together. Things like emissions monitoring as well for carbon footprint analysis is also very important. IoT has very much accelerated how we work in this space and what we can actually do.
So you've supported countless customers in developing smart agricultural solutions. What are the biggest challenges that they face in the process? And how does Avnet TRIA help solve these challenges?
So it's a very interesting one. When you look at the amount of challenges in the space, there are multiple challenges, predominantly environmental. So if we consider things like shock and vibration, very wide operating temperatures, dust ingression, all of these mean that there are some big challenges for our customers when developing embedded systems. particularly when you look at things like HMIs or human machine interfaces. Often these will be in agricultural machinery where the environment can have effects on the display and the system. So we at TRIA often work very closely with our customers around these challenges that they face. So for example, on a human machine interface, this may be sunlight readable displays so that they're actually able to see the display in a high bright environment, or dust ingression so that we make sure that there's no particles of dust that get within the system causing system failure, even down to things like anti-reflective and anti-glare coatings, specialist coatings on the glass, but also things like shock and vibration. If you consider these heavy machinery that they use within the agricultural space is often bouncing around on uneven ground, the machine's vibration from the engines, etc. These are all aspects that we have to take into consideration around how we support the customers and making sure their systems are rugged enough to work in the environment they're chosen for, but also that they stay running so that there's no downtime and impact to the customer's crop rotation or harvesting process. Downtime is critical for these customers because it means money that they're losing and also degradation of crops and plants whilst the systems aren't running. We have a lot of experience with these types of applications, so we know all of the pain points that the customers typically face, and that's why we are very well placed as a technology partner to people in the smart agricultural ecosystem.
Okay. And going forward, looking into the future, what major trends do you see playing out in the embedded space when it comes to smart agriculture?
It's a very good question. It's a very interesting one that recently I've been involved in a lot of robotics discussions, and we're seeing a lot around agricultural robots now. So, for example, one of our silicon vendors has a customer in UAE that actually utilizes robotics to pick crops. So these are unmanned autonomous mobile robotics that are able to analyze the crops via video analytics with AI to see when the crops are ready, and they're actually able to collect the crops and deliver them back to the facilities without the need for human interaction. So we're seeing a lot more around robotics coming into play. Another aspect is carbon footprint. So we as TRIA have developed a wide range of products, and some of them, for example, the OSM or Open Standard Module is a very small form factor, very low power envelope module, which also means that when you're looking at multiple products out in the field, your total power envelope is very low. This is becoming very key because obviously electricity is scarce, it's becoming more costly, and renewable energies have still got a way to go before they are highly efficient. So by offering our customers the options to go down a strong performance but a low power consumption device, we can also reduce our carbon footprints when looking at multiple devices in the fields. Another area that we see is becoming more prevalent is functional safety, where we have people and machinery working together. Functional safety is a big aspect of smart agriculture, particularly when looking at machinery such as tractors or combine harvesters. And it's a set of measures taken to ensure that a system meets certain safety requirements. In other words, it's a way to make sure that the system can operate safely without causing any physical injury or damage. And that's also another area that we're seeing a lot of interest in and a lot of regulations coming in different areas globally.
And you briefly touched on AI when you were talking about the fruit pickers. Where do AI and edge analytics fit into the picture, and how are they enhancing agricultural operations?
So AI, along with edge analytics, help us to manage complex tasks within the smart agriculture and crop space by adding features such as neural learning with AI camera feedback and sensor feedback. And this allows us to start analyzing object detection, things like predictive maintenance and robotics, interactions with cobots, etc. AI is really accelerating the speed at which we can create and develop algorithms for crop management, soil management, even down to things like cattle management and health management. So with AI, we're able to do a lot more than what we used to do a few years ago, a lot quicker. This also allows us to crunch and share that data with other areas within smart agriculture to be able to get a better picture of things like carbon emissions from cattle mixed with the carbon consumption from plants and crops. AI is also opening up new areas such as simulation. So what we can now do is take a piece of land, do some aerial topography via drones with AI. We can manage the layout of the land and also look at things like the soil content of water from 100, 200 feet up in the air. This allows us to say, okay, this potentially could be a good piece of land for this type of crop, for example, but it won't be for that type of crop. We can then utilize that information to better source land and also better manage the crops and or livestock that go onto that land by utilizing the AI data. It also allows us to simulate what that land may look like when we put a certain type of crop or a certain type of livestock there and see what the outcome is before actually losing real human hours in investing time into that land.
Yeah, so it's really a far cry from our grandfather's farms back in the day. So could you share a couple real-world examples of smart agriculture projects where TRIA has supported customers in bringing innovative products to market?
Yes, of course. I'll give you one example from a crop side. So one of our customers approached us where they wanted to create a smart greenhouse and they required an IoT gateway. In essence, the data from the greenhouse would be sent to a centralized system at the farm's headquarters for analysis. The system then assisted the farmers to estimate production times and volumes for individual greenhouses and crops remotely. And the ethos behind the total system is to aid higher yields of crops by managing the exact time at which to pick the crops within the greenhouses, and also by eliminating excess waste where crops were picked either too late or too early. The system was developed with TRIA for harsh environments, with moisture and dust being key factors to consider, and in addition, high operating temperatures meant that the design and manufacture of the system was based on our standard building blocks into a fully custom foulness and ingress protection rated system with a very high level of shock and vibration due to the amount of machinery and people working within that environment, as well as being able to operate in very wide temperatures, obviously very cool in the evening and very warm during the day within the greenhouses. And this was all wrapped up with cutting-edge connectivity, utilizing a combination of fail-safe wireless technologies, along with some of our software services offering for edge-to-cloud connectivity, ultimately giving the customer a full turnkey IoT gateway solution specific to that type of application use case. Another example is one of our customers has a smart HMI that goes into tractors, and these tractors are used for crop harvesting and crop management. And this posed some extreme challenges, as I previously mentioned, but in addition to the system, they required functional safety certification. Functional safety is something that TRIA can offer. It's a very resource and labor-intensive process. There's a lot of stringent certification requirements that need to be adhered to. And alongside this, we wrote a specific piece of software that enabled the customer to switch between various silicon vendors depending on the application or the tractor it was going on to. For example, if it was a small system, they could standardize on the custom platform, but change the smart module within inside from a low-powered ARM CPU up to a high-powered x86 CPU without the need to redevelop their software application. This meant they could very quickly standardize on one product, but switch the performance depending on what the tractor and or end application was going to be. And this is something we call simple switch. And it enabled our customer to get to market very quickly with a multitude of HMI offerings, coupled with a 12-inch high-resolution display, sunlight-readable, anti-fingerprint, anti-glare, and anti-reflective coating, so they could go to market with a wide variety of products very easily.
Yeah, that switchability is a really nice value add for your customers. That's interesting. So technology has always been deployed to improve metrics like increasing productivity or cutting costs. But do you see IoT technology or maybe AI playing a role in reducing carbon footprints and promoting sustainable agricultural practices? And can you walk us through this?
100% for sure. AI and TRIA together are working towards a carbon neutral footprint. With the boom and acceleration of AI capabilities from our silicon partners and vendors, we are starting to see a shift towards low power footprints, as I mentioned before, such as the OSM. That keeps the total cost of ownership and of energy very low, with standby sometimes as little as 1 milliwatt. if you think you have several hundred devices out in the field, AI can manage which devices need to be in sleep mode and which need to be awake, and also manage how much power they're using. In addition, AI can manage things like sensor data, and they're able to adjust machinery output. So, for example, a tractor may be working harder than it should be or accelerating higher than it should be. AI can efficiently manage the acceleration of the engine to help reduce the emissions from those vehicles. Also, utilizing data such as air quality, we can also manage crops in terms of how much water and fertilizer we add to them, or even down to things like cattle with methane emission, and also managing how we rotate that cattle in order to spread the methane extraction out into the atmosphere. To add more depth to that, many manufacturers of agricultural machinery are now moving towards EV, which means they're replacing the powertrains within their historically dirty fossil fuel emissions down to EV. Something like 13% of all commercial vehicles make up what we have in terms of transportation. However, their impact on the environment is far higher. It's sort of 30 to 40% in terms of emissions. And this is predominantly due to their long working hours, heavy emission engines, large engines. And by utilizing AI and IoT, we are able to manage the emissions and the drivetrains of these systems more efficiently and help towards sustainable models through things like simulations and air quality control.
Okay, so that's quite considerable. That's interesting. So all this has been quite fascinating. We've covered a lot, but if you had to boil it down to 3 takeaways for our listeners, what would they be?
So if I had to boil it down, I would say smart agriculture combined with AI, IoT, and embedded technologies. We consider 3 major human aspects to it is food security, risk mitigation, and adaptation. We're moving into a world that's very fast-paced and quick-growing, particularly on the AI and IoT scenes. By adapting and embracing these technologies within smart agriculture, we're able to reduce our risks of things like food shortages, whilst at the same time lowering our carbon emissions. We need to adapt with these technologies to keep our planet growing for the masses, whilst ensuring food security and longevity for the generations to come. TRIA is at the forefront of these smart technologies, and we endeavor to bring our customers into the new AI, smart IoT era by leveraging these key capabilities and competencies that we have within the business, coupled with our cutting-edge products and services. We really are a technology partner, not just a supplier, into the smart agricultural space.
All right, excellent. So now we've already reached the end of the episode, but at the end of each episode of the Technology Addicts, we ask our guests the same question. What would you say is your current technology addiction? It could be anything from a gadget that you recently bought to an entire field of technology that's captivated you.
For me, it has to be, and I alluded a little bit to it, is robotics. Robotics is a very large compound annual growth rate market segment, and it's one that I'm doing a lot of exploration into now, and we do have some customers in this space. However, the speed at which robotics is growing, even in the agricultural space, is quite scary in terms of how fast it is actually accelerating. But there are some very interesting technologies in there. We're starting to see things like humanoids, a robot that looks and functions almost like a human being, actually doing things like picking crops or building a vehicle in a vehicle facility. There are driving factors behind this, such as aging populations and reduced workforce. And I find it a fascinating area, and it's a passion of mine that's growing quite rapidly.
I'll have to look into that. That sounds very fascinating. With that, I'd like to thank Bevan for joining us for this episode of the Technology Addicts podcast. And dear listeners, if you'd like to get in touch with Bevan, you can reach out to him. So you'll find all of the contact information in the show notes. And to everyone listening, thank you again for joining us today. And stay tuned for the next episode of the Technology Addicts.
Thank you.